Hello, good afternoon, everyone. Today, first of all, I would like to introduce you all to me. My name is Paras Singh, and in this class, we'll be learning about Introduction to Bridge Engineering. I'm a third year BTech student at Civil Engineering at MIT Academy of Engineering. So, first of all, as you all know, you must be familiar about the bridges around you. So, what is the need of bridge? One simple answer may be we need bridges for transportation across the rivers also and across huge monuments where uh, physically we cannot uh, physically we cannot go. So they are very important and they are for global infrastructure and connectivity. Means they provide us connectivity in the roads and they are hence important. And in this presentation, we'll learn about the bridge types, the components of the bridges, what are the various types of components, the loads, the types of loads that are imposed on the bridges, the failures, the common causes of failures in the industry that leads to failure of bridge and loss. It may sometimes also result into the loss of life of people and safety protocols that we should follow in bridge engineering. And as a fun fact, I would like to tell you that the global bridge market was at $125 billion in 2023. So as I mentioned earlier, first of all, we'll go to the topic classification and types of bridge. Uh, Means we will differentiate bridges. What types of bridges are actually there? We'll know more about it. So first is the bifunction. Means what type of function of bridge is built for. The common functions are roadways. Roadways, in the roadways, you might be well aware that vehicles such as your motorcycle, your car, and trucks transport through it. The railways, in the railway, the rail goes through, the train goes through the bridges. The pedestrian bridges are also there, which are meant for only the pedestrian walking public, and utility bridges are also there, means for transportation of goods. And pedestrian, in case of pedestrian, there may be weak bridges also, the wooden bridges in the villages, and strong bridges serve all the purposes. Second is the by material, means what kind of material is used for the construction of the bridge. So the types of material that can be used are concrete, steel, timber, and composite material. Concrete is the most common, as you all know. You have seen concrete bridges all around you. Steel is also second most popular, as we all know. Steel bridges are huge bridges, and sometimes the reinforcement is also done. The cables are provided in the form of steels that support the extra load that is imposed on the bridge. Third is the timber bridges. Timber bridges may seem weak, but they are also super strong when built by interlocking mechanisms. And the final is the composite material. The composite material is the mixture of various materials and it dominates the bridge construction. Third is the bistructure, means what kind of structure is provided to the bridge. So there are various type of structure such as beam structure, means simply supported bridge is there. There is no huge, humongous architecture involved in it. Second is the arc, means the curvature is given to the bridge. Third is the suspension, means the suspended bridges are there. Sometimes hanging bridges also you might be well aware. And finally, the cable state types means they are supported by the cables. Usually, the cables are steel cables, I have mentioned earlier. And the final is, and lastly, I would like to tell you about the market share. Means what in the market, what kind of share is there for the bridges. So in the global market, total 60% of bridges are of concrete bridges. Means concrete is this predominant in the bridge engineering. Next, we'll move on to the components of the bridge. So, what are the various components of the bridge? We'll know that. First of all, superstructure. The superstructure is the above part of the bridge that we can see. So, first of all, the first superstructure component is the deck. Deck is where the vehicles move. Second is the girders. Girders are supporting cables that support the load. Third is the trusses, the type of truss that is given for the load to transfer. The load is transferred onto the trusses, and the truss transfer the load into the foundation. And final is the arches which are given the structure. You can see sometime a curvature structure, and so on. Second is the substructure. In the substructure part, there are the piers. Means piers are the foundation part. Second is the abutments. The abutments are below the surface of the soil, subsurface. And third is the foundation. The foundation may be deep foundation, shallow foundation. But in the river side, generally we see deep foundation, and on normal places we can see both deep and shallow foundation, and sometimes other in this types of foundation there is sub classification also. So mat type of mat type of foundation can also be given to this. Also, the joints that are given and the bearings that are provided also play a significant role. And the deck part of the bridge, which is the ultimate part of the superstructure, it is 15 to 20%. Means you can imagine how much costly it is. So it is very important that quality is not compromised in building a deck. So we'll move on to next slide now. Next is the concept of the economical span. By economical span, what we mean is the span should be short, and also the span should be cost efficient to us. First of all, the factors that play a significant role in economical span are the material use, the construction way used, and the maintenance cost of each cost also plays an significant role in the economical span. Second is the optimization goal, means sometimes the viewpoint, the thought process of the contractor may be different, what kind they are building for. So it varies differently according to this. And lastly, we'll know about the typical span length. What is the usual span length that is provided? Firstly, the concrete bridges are usually built 20 to 50 meters. These usually are short span bridges, and the steel bridges are 50 to 150 meter in range. These are mid span bridges, and we can also see huge bridges built. But generally, you will come across only short span and mid span bridges in your day-to-day life or encounters. Now we have learned quite enough from the economical perspective, from the view of what we can say from the view of architecture and from the view of aesthetics. Now we will move on to the as an engineer, we should be well aware of the hydraulic considerations. I mean, we are civil engineers, and as a result, hydraulic considerations are most important. First of all, the afflux. Afflux is the water level that is caused by the obstruction from the bridge structure. This is the very simple concept. When some heavy object is kept, the water level rises, and hence afflux is created. And we should try to avoid afflux. We may not be able to completely avoid it, but we should be able to minimize it and see that the water doesn't come over the bridge. As if the water comes over the bridge, it may result in the blockage of the connectivity, and the people would not able to transport from the road, do transportation from the road. Second is the high flood level, HFL, means it is the maximum water height reached during the flood conditions. Means at the time of rainy season, you may see the water generally comes up, the water level rises in the river, and due to which accidents may occur. Sometimes we may see cases of vehicles flowing away, small vehicles, lightweight vehicles. That is the case. But this should be considered, and high bridges, tall bridges should be built. And sometimes we see the bridges which were built, as an example, you can take 50 years back, are now broken, and in the side vicinity only a taller bridge is built, means extra length is provided to it. So this is very important factor to keep in mind. And lastly, the scour depth. Scour depth is the the amount of excavation done while building a bridge. The lesser the scour depth, the more cost effective the bridge is. And but also we should not compromise. We should not compromise with the quality of the bridge. So, uh, keeping both things in mind, we should construct the bridge. And as a fun fact, I will tell you that each 1 meter increase in scour depth raises the bridge cost by 5 to 10%. Moving on to the next slide, what are the types of loads on bridge? There are different types of loads imposed on a bridge, and these loads may include dead loads, live loads, environmental loads, and dynamic load allowances. And dead loads are generally the self weight. It includes the self weight of the bridge and the cables and the foundation itself, and it is static in nature. We should keep in mind while constructing a bridge. Second is the live load. Live load arises from the traffic loads, and generally vehicles, pedestrian, and trains are considered. and the ultimate load is considered. Live load is generally the moving load or the live load as the name suggests. Third is the environmental load. These loads are calculated by the IS standards. You may refer to IS standards for better understanding also. In the environmental loads, there are various environmental factors that play a significant role. First is the wind load, second is the earthquake load, third is temperature changes, and finally the snow effects. These from if you are building a bridge on Mumbai Harbor, let's say. So there is earthquake chances are less, but the temperature changes, the wind and the water effects are more. But in Himalayan regions, the snow effects are more. In places where seismic activity is more, the earthquake chances are more. So one needs to keep this in mind and also refer to the seismic zoning available in the IS standards. And factor of safety generally 10 to 40% of factor of safety is provided to the loads. So according to the Indian Road Congress, which is another standard followed by the transportation engineering students, the load specifications are given. First is the loading classes. There are three classes of loadings, class AA, class A, and class B. In the class A, heaviest vehicles are considered, such as trucks, and in the railway, trains can be also considered. Class A is standard vehicular loading, which are generally cars and medium range vehicles. And lastly, the class B, which are light vehicles such as motorcycles, your scooty, like that. Second is the load combination. The load combinations generally we take 1.5 into dead load plus live load plus wind load, but it may change according to the specifications. And also the revisions have been given in the Indian Road Congress code in 2017, and we need to consider means it is mandatory means they have made it compulsory for us to include a safety factor. Now we will learn about the common causes of bridge failures. As we all know, every structural building has some failure points in life. So accordingly, uh, bridges also fail during its lifespan. First is the hydraulic failures, means the hydraulic factors that we considered earlier. If not served properly, the bridge may fail according to it. The scouring property is there. If if done in excess, the building may fall. Erosion property is there. The concrete bridge may erode due to continuous weathering and climatic changes. Third is the flood impacts, and so on. Second is the structural failure, means if the enough loading is not provided, so the bridge may go to structural failure. And last is the impact damage. Continuous accidents occurring on the road may result into the impact damages. Next is the failure of bridges in India. There are various types of failures of bridges. First example is Morbi Bridge collapse in 2022. There were almost 135 accidents happening due to this reason. And so we should be very well aware of what kind of material is used in our construction. And we should uh, give the continuous monitoring, and the government should provide uh, a quality inspector from time to time so that less accidents occur. And second is the Kolkata flyover collapse in 2016 due to this flyover collapse, which was under construction only. 26 fatalities has been recorded, and it is means in a developed city like Kolkata, it is very heartbreaking to see this. And lastly, what lessons we learned from this, that the quality of the bridges should be uh, monitored, and regular inspection and quality control should be given to the roads. Coming on to the last slide, I'll conclude this slide by summing up the lecture for all you guys. First of all, we should give proper design construction to the bridge so that it does not fail. And the cost factor is also important, because if a bridge fails continuously, more it is heavier on the pocket sides. Second is the improved monitoring, means while the construction of bridge is done, to maintain the quality inspector should continuously visit the site. This is the second point. Third is the future trends. The sustainability and advanced material will shape the bridge engineering. Uh, What we understand from this term is that as we all are heading towards sustainable development goals, and smart infrastructure is also one of the sustainable development goals, as you all might be well aware. This is the future of bridge engineering, and we should focus more on innovation part, and focus more on ideas and innovation. Last is the market growth. Means as we have seen earlier in this presentation that already the market is huge. It is huge in nature, and uh, the global market is blooming. And by 2028, it is estimated that the bridge market, will be $45 billion, and that is the huge number. And it will inspire us civil engineers to build better bridges and be honest to their work. I would like to thank all of you for lending your precious time and watching this video till the end. If you have any doubts, you can comment, and I'll be glad to reply to you. Thank you.